Welcome to the lesson on areas of combination of plane figures. At the end of the lesson, you will be able to determine the area of combination of plane figures. Sam's father Joe is a carpenter. In his free time, Sam helps his father with his carpentry. Joe makes wooden furniture. He uses veneer of different colors to design the surface. Last Sunday, Joe helped his father to make a table. Its top had a design that looked like a circle inscribed in a square. As you can see, the circular region is in blue, and the rest of it is in white. Joe now wants to make a table with a different design, and he would like Sam to help him. He shows him the design he has created and asks Sam to cut the blue veneer. Here, Sam can see that the blue portion of the design is not a standard shape and wonders how he will be able to cut such a shape. Joe gives Sam two separate pieces of veneer, one square and one circular. Sam thinks for a while. Then he gets an idea. He places the circular veneer in the center of the square and draws an outline of the circle. Then he places the circular veneer on one corner of the square veneer and draws an outline of the quadrant of the circle. Similarly, he marks quadrants on the rest of the corners. Finally, he cuts the marked portions of the blue veneer. Voila! There it is! He found a technique to remove the unwanted areas from the veneer to get the required design. Here's a recap of what Sam did. He took a blue square veneer, marked a circular shape in the center, and 4 quadrants on the corners. Then he cut the marked portions. If Sam wants to find the area of this shape, he simply has to subtract the area of the cut portions from the total area. In this case, the cut portions are a circle and 4 quadrants of a circle. That is, the area of the square minus the area of the circle minus the area of the 4 quadrants. Now, we will see how Sam and his father plan to make a door for the restaurant. The design of the door looks like this. It is 2 meters in height, 2 meters in width, consists of 2 wings, and the outer shape resembles a square. They would like to use glass and wood to make this door, where the glass occupies the semicircular shape on each wing of the door. Again, the combination of standard shapes, square and circle, is involved in the design of the door. Here they will have to cut 2 semicircles from the square that has a side of 2 meters. Now, they want to order the glass for the door. For this, they have to calculate the area of the glass required. You can observe that the glass portions of the door are semicircular in shape. Therefore, the area of the semicircle is the area of the glass. The diameter of the semicircle is the height of the door, which is equal to 2 meters. This implies that the radius is 1 meter. Recall that the area of the semicircle is half pi r square. Therefore, the area is equal to 1.57 square meters. Therefore, the area of the glass required to make the door is 2 times 1.57 square meters, that is 3.14 square meters. Then, what is the required area of the wood? The wood required is equal to the total area of the door minus the area of the glass. The door resembles a square, where each side equals 2 meters. Therefore, the total area of the door is 4 square meters. So the area of the wood required is the area of the door minus the area of the glass, which is equal to 0.86 square meters. This means that Joe needs to buy nearly 1 square meter of wood. This is the advantage of designing on paper before building anything. So far, we have seen how Joe and Sam worked on furniture. Now, we will see a few more examples of how the areas of non-standard figures are calculated. The examples we will see here involve basic geometric figures such as circles, squares, triangles, rectangles, etc. Look at the first example. Here we have to calculate the area of the figure which has a non-standard form. Let's try to analyze the figure. We can visualize the figure as 3 parts. It is a combination of a rectangle and 2 semicircles. Therefore, the area of the figure is the sum of the areas of a rectangle and the 2 semicircles. Let's see another example to understand the method better. Here's a figure composed of 2 concentric circles. To obtain the area of the shaded region, let's follow the procedure. Now, the area of the shade region is equal to Here's another example. This figure is a combination of a circle and a square. Here we have to find the area of the shaded region. Let's analyze the figure. You have reached the end of this section. Before moving on to the next section, let's recap the key points covered. In this lesson, we have tried to understand that a non-standard shape is composed of different standard shapes. We have also seen how to calculate the area of the non-standard shapes. Hope you enjoyed this learning experience.